Hi, I'm Patrick Coyle, and this is Probabilistic Programming Primer Introduction to PyMC3. This is going to be a really short screencast. I'm going to talk a little bit about what PyMC3 is and what its features are. So basically, uh, uh, probabilistic programming allows the flexible specification of Bayesian statistical models and code. This is kind of a recent invention. One of the reasons this is a recent invention is that for years there were limits on our computational ability to solve some of these problems. So we could write down examples, we could write down equations, but we couldn't solve them analytically, and we needed to wait for better computers and better algorithms to come along. So basically, what happens whenever you're building a probabilistic programming model is you need to use something called a Markov chain Monte Carlo sampling algorithm. And this is really your magic box that lets you do your inference. The modern versions of these sampling algorithms are called, include things like no U-turn sampler. A no U-turn sampler is basically a self-tuning variant of Hamiltonian Monte Carlo. And we'll get into more depth later on in the course about what these things actually mean. But from a practitioner point of view, your take-home point can be that this just allows you to work better on high-dimensional problems and complex posterior distributions. And there are various like self-tuning strategies out there that work in these algorithms. So we'll get a bit more into that later on in the course. Now, in terms of having these abilities, very few libraries do. PyMC3 is one of them. Stan does. There's a few other ones like Laplace's daemon package in R. And recently I've heard that there's a new version of Scala. So this is quite state-of-the-art technology that you won't get anywhere else. So let's talk a little bit about PyMC3 features. I'm a Pythonista, so this is a big selling point to me to get involved in the project, was the fact that it allows you to do everything in Python. So let's talk a little bit about the features, because as practitioners we care about features. It allows you to fit Bayesian statistical models with MCMC. We will not have time to talk about other things like variation inference and other algorithms, although there are other algorithms implemented in PyMC3. It includes a large suite of well-documented statistical distributions. So for example, if you remember from your mathematics courses, you'll remember things like Poisson distributions, normal distributions, and we'll see examples of these later on in the course. This here is really important for me as a practitioner. It allows you to create summaries of including tables and plots. The traces are the result of your sampling algorithms. Can be saved to disk and you can store them elsewhere. You have things like convergence diagnostics and model checking. We're going to see a little bit more about this later on in the course, because it's really important to diagnose your models and tell you how good your models are. It's extensible. You can create your own unusual probability distributions or custom step methods, and you can embed things in larger programs. So in this course we're going to see the basics of how to use PyMC3. We're going to have a simple example to start off with. We're going to do things like data creation, model definition, model fitting, and posterior analysis. Then we will cover 2 case studies, and maybe a few more, and we'll see how to define and fit more sophisticated models. And later on in the course we'll talk about more sophisticated methods. We'll talk about the general linear models subpackage, things like custom distributions, custom transformations, and alternative storage backends. That's it for this little screencast. I hope to hear from you. I hope you can join me soon later on in this course.